Hi, I'm Darryl, and this is ordinary playground sand. And what we're going to do is we're going to sterilize this and clean it in the most extreme way that you have never seen before. Sometimes I have to get my mind off things, so I like to do fun little experiments that really have nothing to do with anything I've typically do. Just fun little projects. That is our sand. So first step is going to be to wash it. Just boil some water here. Make it about half and half. And this water is at 78.6 Celsius. So I don't know if you can see that, 78.6 Celsius. It's really, really hot too. Yeah. And let's start the watch here. Let's see. I'm gonna let it soak there, and add just a few drops of detergent, not too much. There we go. And I'm gonna mix it. Because I want to make sure that this water with the soap in it dissolves into every little air pocket of the sand, and all the sand gets wet. Plus, in mixing it, I want to make sure that this detergent has a chance to penetrate all the grains, well, not penetrate, but expose itself to all the grains, and therefore clean every particle of sand. So I'll be doing this for a while, so I'll cut off now. So the sand has just reached 59.2 Celsius, and I'm going to let it settle. So at 448, or is that 59.2 Celsius? And I'm just gonna let it settle for a bit. There you can see it. We should have a lot of that tiny microscopic debris absorbed into the soapy solution there, solvent, solute, whatever you want to call it. And we'll get back in a moment. Okay, so what I noticed more or less is that there's a tiny little film that settles on the top of the sand, and it's probably hard to see, so I'm giving it a good stir right now. And as those particulates of that tiny sediment, that more refined sediment, is starting to settle on the bottom, I am going to pour it into the sink. Just try to get most of the water anyways, before that finer sediment can can settle onto the sand there. And then okay, so I see a little bit of a a regolith here. You can see some really dirty crud there at the top, so I'm going to scoop that out. So let's see here. I guess there'd be a little bit of an art to this, if you will. Let's see here. This must be soil. Yes, let's get rid of some of that. So apparently I don't have all the tools to really do a truly good job of this. I'm just going to strain some of this water out. And now I'm going to so if you see that, because this is playground sand from the Edmonton playground, we've got some tiny amounts of dirt embedded in that sand. So this is a bit like shifting, I guess you could say, like shifting for gold, whatever the proper term is. And I'm going to try to, there we go. There we go. I'm going to reboil some water and we're going to give it a good rinse. Well, here we add some freshly boiled water. This water should be at a slightly higher temperature. Oh. And this is 76 Celsius. Yeah, it's about 76. Now I'm going to repeat this step. And this step is partially to dissolve the extra soap thereafter, and to also dissolve some stuff that isn't sand in the hot water there. And this hot water treatment in its own, we're going to repeat this several times to get any soluble contents that aren't actually particles of sand dissolved into the hot water, as it were, until the water overall becomes clear. Now the good thing about the detergent is that it floats to the top. Sand is primarily made of calcium carbonate and silica, and I suppose there's some limestone in there, and it's primarily quartz, so a lot of it is quarried from quartz. And there's a stuff called, and sometimes this quartz can get ground up into silica and get into people's lungs in its own dusty form, as it were. But because all the sand is composites of, I suppose there's some dead seashells in there from marine life long time ago. That's also calcium carbonate and rocky sediment like quartz. These won't dissolve in just normal hot water. Okay, there we go. Now what I'm going to attempt to do here is put it at a bit of an angle so that most of the sediment that is forming will go to one side of the sand, and hopefully I can scoop some of that extraneous sediment out. But there's a lot of really light sediment that's in there. So we're going to take the super light sediment here and we are going to pour it out. Of course, I'm losing some. There we go. Yeah. And I'm going to boil some more water and repeat the process. Okay. So here we go again. We've got 77.8, and as you can see, the water is generally a lot less cloudier, and this, as far as I'm concerned, is a good sign. That means that we've got some of this the soluble impurities out of there, because we've been dissolving it into the hot water. And some of the finer particulates that don't exist in this, that shouldn't exist in the sand, has been dissolved or has been, trying to find the word, animated in the water because of their less density. Yeah. So, of course, the science of this is really, really crude. Okay, so. Let me call this third rinse at 77.8 Celsius. Yeah. But this is also sterilizing any microbes or bacteria or viruses that cannot survive within the above 70 region. So we'll get back in a bit. So as crude as the science is, I've learned that soil, planting soil or soil just from the ground, is definitely a natural contaminant of playground sand. This water here is at 76.4 Celsius, and this is our fourth rinse. You can tell already the sand is starting to get cleaner, just because of those soil impurities have been taken out. You can see how much clearer that water is. So that's the fourth rinse, yeah. 77, yeah. So this is obviously an important step in cleaning the sand. You can tell by the less suds there, most of the detergent has been removed because very little of it is actually creating bubbles. There's hardly any bubbles on the surface. And detergent tends to float to the surface in the form of bubbles, the bubble film that it makes and so forth. I'm going to pour this out. I've got a very small trace there of soil. I'll get rid of that. And this is how our sand is evolving thus far. Now I figured some radiation might help in our overall process. So we're going to microwave our good sand. And I'm going to go power. Let's do 3 minutes, yeah. And I don't know if you can see in there, this screen always seems to get in the way, but we are microwaving our wet sand. Okay. Some popping going on. Oh yeah. So we'll get back to you after that. So I microwaved our sand for about 1 minute 19 seconds. And I should have added more water during the microwaving process, so I'll do it again after my next steps here. But basically now we're going to boil the sand. Yeah, so the whole process has taken about 30 minutes thus far. Oh, we've got some smoke there. That's not good. Well, hopefully that will burn off. So I'm going to start my stopwatch. There we go. Start. And this will basically kill any bacteria that can't tolerate the heat. Since we're in Edmonton, it's at 58 right now. 59. Uh, 60. Since we are in Edmonton, we're 666 meters above sea level, and because of that, the water won't boil at 100 Celsius, but it will boil probably around 96, 95, 95, 96, 97, something like that. So we did a little pre-microwave of the sand, the wet sand, but I found that there's pockets of water in the soaked sand, and they were rapidly expanding into gas because of the microwave, and so sand was sort of popping up and down like popcorn in a bit. But yeah, so 71. Yeah. So I'll get back to you with this. Okay, I've boiled the sand for 33 minutes 48 seconds, around 95 Celsius. I'm going to turn this off now, and we're going to let the sand settle a bit. It's going to take a while for it to slowly settle down from its... The good part about the boiling is that as the water expands at the very bottom of the pan, it mixes the sand up into the surface as the air bubbles at the bottom want to move to the top, and they violently explode sand up through the surface, and you get this agitation of sand through the water. So I found, all in all, that I didn't have to mix it very much. The boiling seemed to mix it for me. As you can see there's some really dirty residue. I'm not sure what that is. It's probably just that much more impurities, and I did wash this pan before the fact, but you can see there's a band there too. Those are probably a few other impurities that have solidified onto the side of the pan there. But we can see the boiling action is starting to decease. So typically water boils at 100, but because we're so high above sea level, the water is probably 96, 97. But the temperature of water, I found, drops very, very rapidly. And, okay, so we'll get back to this in a couple minutes there. So welcome back. The water has settled, and now we're gonna pour some of this dirty water out. So we put the hydrogen peroxide in there, just a typical pharmaceutical use. And what you will notice is a bubbling. This is the hydrogen peroxide reacting with any of the impurities within the sand and essentially destroying them. Hydrogen peroxide is really good for destroying biological elements that are primarily of dead tissue. And it's a bit of a bleaching agent through its oxidation process. It's being H2O2, it releases that first oxygen molecule. So I'm going to be doing is stirring this up. And I might go one further. Let's put this lid on. And just really shake that sucker out. Shake it, shake it, shake it, shake it. And you see that foaminess there. This is tiny bubbles of oxygen being released. Is that hydrogen peroxide is that extra oxygen molecule is atom is reacting with some of the impurities within the sand itself. But hydrogen peroxide isn't the best agent for killing bacteria. So when I empty this out, we'll be back, and we're going to use something powerful. I've been soaking this sand in solute of hydrogen peroxide for 24 minutes now, and it keeps bubbling up. I had to shake it vigorously many times, and now I'm going to pour this out. 24 minutes in hydrogen peroxide. Now I've been using tissues here just to soak up some of the excess water. And in this case, the excess hydrogen peroxide. And we are now moving on to our next step. So I'm going to use this tissue here just to soak up some of this excess here. Now we're going to go with some serious sterilization. So it's been oxidized for 24 minutes. I'll write that down. 24 minutes. Oh, we still got some more in here. Oh, brother. Now we're using bleach. This is the real deal, baby. Bleach kills the AIDS virus. It kills literally everything. And every time I think I've gotten it all, there's always some extra hydrogen peroxide, which I'm trying to remove, so there's less reaction with the bleach. So now I'll take some of this bleach. And, yeah, we've got some reaction there. But I'm going to pour a good amount of bleach. And I'm going to be shaking it throughout. Now I'm going to start timing it too. And yeah. So 24 minutes soak in hydrogen peroxide, starting the timer on the bleach. And I'll be shaking it throughout and I'll get right back to you. So we've bleached this for 20 minutes now, coming on to 29 minutes, and I'm going to remove the bleach. And I'm going to use some tissues here to soak up any excess bleach. Now, because bleach is primarily made from salts, there'll be bleach salts left in this this sample here. So what we have to do is go through a couple rinses. So I'm just boiling some water right now to do that. Oh, bleach, 21 minutes. Now so here's our bleach sample. I had to shake it several times for the bleach to fully react with it all. The first rinse will absorb some of the bleach and get some of that out of the sample. The second rinse should help in dissolving some of the bleach salt crystals that will be left over, and the third rinse is just more of a purity. See, we've got some of that excess there, so that I soak that up. So we'll be back after I finish that. Now I just boiled some new water here. Pour a good amount of that water. We've got 77.6 on the digital thermometer. I'm going to mix it up. The idea of this is to dilute the bleach that's settled onto the crystals, onto the sand, and absorb some of that, some of those bleach crystals that are left, because bleach breaks down into crystals. So, bleach by itself is not as harmful as you'd think. People tried to commit suicide using bleach, but usually found themselves to be vomiting most of the bleach out. See, rinse, at, yeah, 77.8 Celsius. I'm just giving it a good mix, and we'll get back. Okay, we're back. And I just did the first rinse to get the bleach out and dissolve some of those bleach silk crystals. And we're doing the second rinse now. With the water at about, yeah, boiled. Digital thermometer says 77. Might be hotter. See, digital thermometer says 79.6. This is the second rinse. 76. You can tell the sand is pretty clean because, well, dirt-wise, anyways, because the water is fairly clear, even when it's mixed up as compared to the first time we did the very first wash on it with the detergent. I'll get back to you when this is done. Now my third step is going to be trying to remove most of the excess water. Got to wait to do this. See, I'm using paper towel here. Fair amount of sand. I'm gonna spread this out.
Are you still working on that?
Yeah. That's getting down to the water removal process.
It's kind of weird. Is that your obsession?
No, I didn't think you would really understand it. Yeah.
Darryl, I think we should call my strange addiction. That's your strange.
Okay, so then gonna try to. So here I am with my sand, and this is my heater. It will heat the sand up to about 55, maybe 60 degrees centigrade, and this is second last step to achieving that clean sand. So I'm heating the sand. Sand's been left out for about a good hour, just at room temperature, and I'll get back to you after I finish that. Okay, using my digital thermometer, we have a reading of 44.8, 46, 45, 47. So on average about 45 degrees centigrade. I heated up the sand with my portable heater. Top temperature was about 63 centigrade. So it's in the range between 50 to 60 centigrade. And now we're going to freeze it. This is our sand after it's gone through most of our cleaning process. I don't know if you remember how dirty it was at the beginning. Maybe we'll do a side-by-side clip here. Let's see here. So this is what it looks like. Okay. And we're going to stick this in the freezer. So, here's our freezer. Stick our sand in there. I measured the temperature of the freezer. It's about minus 12, minus 11, so at least it's minus 10, right? So I'll freeze that for a few hours and I'll get back to you when that's done. Okay, we're back. This has been in the freezer for about an hour and a half. And we can tell that there's a lot of moisture that has been removed from the sample. And the reason we know that is because the sand is very smooth. If there was moisture in between the grains, it would glue the grains together as the moisture froze into ice. So now we're going to bake the sample. Here we go. This is going to be really truly interesting. Baking the sample at high 260 degrees centigrade will surely remove any water from the sample and sterilize it furthermore. Plus, when all the water is removed from it, there will be no medium for any microbes to reproduce, and some microbes can reproduce and replenish within, they can double in populations in 20 minutes time, so I've never done this before, but it should be interesting. I'm just trying to spread it out nice and evenly. So there's our pan. And the oven is quite hot there. You can see that. We are baking the sample now. And I'm going to start the timer. So we froze it at about -10 for about an hour and a half. And I'm starting the timer now, so I'll probably bake it for a good hour, and then I'll get back to you and show you what happens later. And there you can see the sand is baking. I measured about 123 Celsius with a digital thermometer here. 148, 149, 150 Celsius. So, so right now it's at about 150 Celsius. I already started the timer. And this is going to be fascinating. I just have no idea how this is going to react. I have no idea if it's some of the sand's going to expand and crack or crumble, or if it's just going to get really hot. I don't suspect any of it would melt, because rocks don't typically melt unless they're like within the thousands of degrees centigrade. So if anything exciting happens, I'll let you know. Typically we're 10 minutes into baking, and most organic material probably burn off around 252 Celsius. In this case, wood will spontaneously combust at about 272 Celsius. So right now we're about at 260, yeah? And let's see here. Yeah, we're floating around about, well, the digital thermometer is giving me about 116, but so maybe we'll cook that for another good 10 minutes or something. Just bake it. Right now I'm baking it dry without water, right? So this is the dry attempt to I saw a little bit of smoke come up, so this must have been some organic material that was just smoking up. And, it's pretty cool, actually. Doesn't make any smell that I can notice anyways. This is where I've been taking my temperatures from. 120, 122. Almost got 131, 132. There's a little heat vent, more or less. There's the setting. So we're at 260, right? So we can turn it all the way up there. And now, okay, it's been about 25 minutes. And so I'm gonna wait 5 more minutes. The temperature is way too high for me to measure with my digital thermometer. It's well above 177 Celsius for sure. Now, I said before, wood and organic material combust at naturally at 272. I'm not sure about that. I believe they begin to burn in the high hundreds. Anyways, this would burn up all the organic material that's left in the sand, so this would be the final purification process. Okay, so it's been 27 minutes, so I'm going to turn off the oven, and we're going to take our sample out. Super hot sand, and we're just gonna let it cool above here. And sand is very hot. I'm having trouble measuring it with the digital thermometer. But this sand is dry. Yeah, I'm talking bone dry, drier than any sand that would be in the desert. The point of putting it into the oven at such a high temperature was to evaporate every molecule of water possible from the sand, because water begins to be a breeding ground for microbes and bacteria. Okay, I'm measuring the sand now at 143 Celsius. There we go. 149. So I guess the sand is cooling rapidly. Oh no, look at that. Some of the sand is 129, 136, 143. This is 161. Holy cow. Some crazy temperatures here. So we'll let that cool, and so I baked it at the highest setting on the stove for a good 27 minutes. So, and we'll get back. Okay, so I am back, and I'm not sure what the temperature of this is, but I'm quite confident it's fairly cool. So I'm going to pour it into here. Yeah, definitely room temperature if anything. And here is our finished product. Clean, sterile sand. Remember, we first cleaned it with a little bit of detergent at 78 Celsius. Almost for 5 minutes we did that, stirring it in that detergent with just detergent soap. And then we did 3 rinses. Each rinse was at an average of 75 to 77 Celsius to get the detergent out. We microwaved the sample for 1.2 minutes. 1 minute 21 seconds. We boiled it at about 96, 97 Celsius for 33 minutes, 30 seconds. We oxidized it with hydrogen peroxide for 24 minutes. We bleached it for 21 minutes. We rinsed it again at 77.8 Celsius. We rinsed it again at 76 Celsius. We slow dried it for 20 minutes at 50 to 60 Celsius. We froze it for 1 hour and 30 minutes at minus 10 Celsius, and we baked it from 168 Celsius to 175 at the highest setting on the oven for 26 minutes. So this sand essentially has literally almost negligible amount of moisture in it. It is sterile, bacteria free. There's no sign of any living organism would have had its protein coat denatured, destroyed, killed, and essentially burnt and carbonized. And it. And so each step had a process, and took quite a few hours to run it through all the steps. Of course, there were some flaws in the technique. You know, I used some unsterile equipment like tissue papers and towels, like paper towels, to soak up some of the excess water during different parts of the stages. I didn't wear latex gloves to keep the sample absolute sterile. So I mean, there's some room for slight contamination, but for all and most purposes served, this is the most sterile and cleanest sand in the world, and would simply not occur in nature.